As we dive into the physiology of the large intestine, remember that we're only talking about the final section of the digestive tract. It includes the following sections: cecum, colon, rectum and anal canal. Together, they form the widest and shortest part of the digestive tract. The proximal large intestine is responsible for absorbing water and electrolytes. Next, the distal intestine stores fecal matter until its expulsion. Said functions don't require the colon's movements to be as intense. At least, they aren't as intense as in the previous sections in the digestive tract. In fact, these movements are slow and gentle. As a result, the colon's movements are similar to the movements of the small intestine. Peristalsis. This term describes the contraction movements of the digestive tract. It aims to move fecal matter to the anus. In other words, these movements are intestinal propulsion movements. Read Fruits and Herbs to Soothe Digestion. Physiology of the large intestine. Bowel movements. Identical to what happens in the small intestine, bowel movements can be split up into mixed and propulsion movements. The mixed movements are a combined contraction of the colon's circular muscle and longitudinal muscle. This pushes the non-stimulated part of the colon outwards in a sac-like shape, called a haustra. Minutes after, the process repeats itself a little further, pushing the fecal matter farther along the large intestine as if to milk it. By pushing in this manner, all of the fecal matter stays exposed on the intestinal wall, facilitating the hydroelectrolyte absorption. The propulsion movements depend on the mass movements. These movements are a modified form of peristalsis that unify the movements of the colon. They push the fecal matter forward. Mass movements occur 3 times a day, lasting 30 minutes each time. How do these movements begin? The mass movements react as a response to the distension of the stomach and duodenum, gastrocolic and duodenocolic reflex. At other times, they might act in response to irritation. An example of a case of irritation is such as what happens in the cases of patients with ulcerative colitis. Role of the ileocecal valve. The ileocecal valve prevents chyme from flowing back to the ileum once it's reached the colon. The contractions of the ileocecal sphincter control chyme. In addition, the reflexes of the cecum control the peristalsis in the ileum, aiding to prevent backflow. When the walls of the cecum distend, it sends out signals that increase the contraction in the sphincter and inhibits the intestinal peristalsis. What happens if these processes change? Generally speaking, excess intestinal motility leads to a reduction of substance absorption. Thus, diarrhea, or soft stool, results as a consequence. A defect in the intestinal motility causes an increase in substance absorption. As a result, hard stool forms, later causing constipation. Physiology of the large intestine. Defecation reflex. The defecation reflex gives rise to the expulsion of feces. Intrinsic reflex, driven by the enteric nervous system, though it is too weak by itself. Parasympathetic reflex, propelled by the pelvic nerve fibers and acts as a reinforcement. How does it happen? When feces reaches the rectum, it signals the walls to distend, which sends afferent signals through the myenteric plexus. As a response to the signals, peristaltic waves flow from the colon downwards towards the rectum. By doing so, they push out fecal matter from the anus. When feces reaches the rectum, it signals the walls to distend, which sends afferent signals through the myenteric plexus. The myenteric plexus emits inhibitor signals that relax the internal anal sphincter. As a result, when the peristaltic wave reaches the anus, the feces continues moving forward. The external anal sphincter is relaxed consciously. On a different note, when stimulation hits the nerve fibers of the anus, they send out afferent signals towards the spinal cord. Signals travel through the parasympathetic nerve fibers of the pelvic nerves, boosting peristalsis and helping relax the internal anal sphincter. Physiology of the large intestine. Substance secretion. What substances are secreted? In the large intestine, only one kind of mucus makes up the secretion that contains controlled quantities of bicarbonate ions, pH greater than 8. The mucus cells in the digestive wall and crypts of Lieberkühn, tubular glands in the small intestine, secrete this mucus. Different epithelial cells secrete the bicarbonate. The secretion itself is responsible for the alkaline pH of the mucus. How is the mucus made? The mucus secretion forms through the direct stimulation of the mucus cells. However, this also raises the response to a stimulation of the pelvic nerves. Parasympathetic innervation. What functions does mucus secretion have? The secretion has 3 functions: protects the intestinal wall from possible scarring and from fecal acids. Mucus pH is greater than 8 because of the bicarbonate ions. Keeps the fecal matter together. Protects the intestine from bacterial activity. You didn't know? 8 signs that something is wrong with your intestines. Physiology of the large intestine. Substance absorption. The large intestine receives around 1,500 milliliters of chyme each day. It mainly absorbs most of the water and electrolytes that it contains in the proximal colon. As a result, the eliminated feces only contain around 100 milliliters of water and anywhere between 1 and 5 meq of sodium and chlorine ions. How does the large intestine absorb substances? It absorbs sodium by active transport through the Na-H exchange. Thanks to the electrical gradient, some of the chlorine ions move passively into the interior of the cells. The rest of the chlorine ions are absorbed in exchange for bicarbonate ions. The intestine uses active transport to absorb potassium, along with other ions such as calcium or magnesium, as well. The unions between the cells of the large intestine are much narrower than those in other sections of the digestive tract. As a result, they prevent retrograde diffusion of the ions and thus allow for more sodium absorption. Aldosterone is a big aid in sodium absorption. The resulting concentration gradient allows water to be absorbed through osmosis. Featured image courtesy of copyright wikihow.com. How to cook vegetables that taste delicious every time. Creativity and knowledge. Now that's a recipe for making appetizing, tasty vegetables. Not sure how to cook vegetables that actually taste as great as they make you feel? Don't worry. There are endless options for serving vegetables, too.